Okay, so we are kind of mixing two things we've learned together, okay? So you guys know how to solve and graph inequalities, right? That's what we reviewed yesterday, and y'all did pretty well. We're also adding in absolute value, which we did, I think, that end of the first 9 weeks or beginning of the second 9 weeks, okay? So we're putting these two things together, inequalities and absolute value. So we've got to make sure we know both of these skills. You should be okay with your inequalities, absolute value, where we're going to have to do a little bit of a refresher on, okay? So when solving absolute value inequalities, there are going to be two cases, and that's the most important thing, that we remember that there are two different ways to get this answer, or two different answers here. So case one is going to be that the expression inside the absolute value symbol is positive, okay? So guys, think about it. What happens when you take the absolute value? It becomes positive. So that means the absolute value of 2 is equal to what? 2. But the absolute value of negative 2 is also equal to 2. So that's where you get your second case, where the expression inside is going to be negative. So you can have a positive number inside or a negative number inside that gives you the same answer when you have absolute values. That's why we have those two cases. If y'all remember talking about this a while back. Some of us. Okay. So we're going to just do a quick review problem. So if the absolute value of x is equal to 4, x can be two different numbers. What? 4, because the absolute value of 4 is 4, and negative 4. So the positive of it and the negative of it. And then again, it's everything that's inside the absolute value. It can be positive or negative.
Oh.
Okay. So review 1 should be pretty simple. The review problem number 2 is just a little bit trickier because we can have that the inside here is equal to a positive number. So is anything going to change? No. So I'm just going to rewrite. X plus 8 can be equal to 2. We're assuming everything in here is positive and it's equal to 2. Or we could assume that everything in here is negative, which would make it equal to what? Negative 2. Okay, so x plus 8 could also be equal to negative 2. It could be equal to the positive or the negative of the inside number. Okay, and to find what x is, we just have to solve for both of these cases. So in case 1, what do I have to do to get x by itself? Subtract by 8, and 2 minus 8 gives us negative 6 for x. And we're going to do the same step for case 2. We're going to subtract by 8, but it's going to give us a negative 10 instead. So again, we have two different solutions here. X could be negative 6 or x could be negative 10. And we could just double check this by plugging it back in. So we could go back up and plug this into the absolute value. I'm going to start with a negative 10. So the absolute value of negative 10 plus 8 is equal to 2. So I'm just plugging in negative 10 for x. Are y'all okay with that? Just to double check. What's negative 10 plus 8? Negative 2. And what's the absolute value of negative 2? So is 2 equal to 2? Yes, so that one's good.
So when you're like plugging into the cases, only the like answer is gonna change from like positive to negative?
So what we'll do is we'll change the answer part.
Okay.
And then we'll have two different answers. Okay, and we can also check for negative 6, so absolute value, and this time I'm going to plug in negative 6 for x just to check that it works, plus 8 is equal to 2. So all I did was replace negative 6 in for x. Well, what's negative 6 plus 8? 2, and it's still in the absolute value. And is the absolute value of 2 still equal to 2? So 2 is equal to 2. So both of these work, and that's why we have to have two cases. We've got to make sure we find both of the numbers that x can be. Okay. Any questions? Because if you have questions on this, then we need to get them answered before we go on. Okay, Steven's just annoyed with life already. All right. Now to review a little bit of our inequalities, if the inequality contains and, the solution is the intersection of the two solutions, okay? The intersection, so only the place where they overlap, which we went over this yesterday. And then if it doesn't contain and, it's going to contain or, which means it's going to be the union, so it's going to be both of the solutions together. So and means where they combine, where they're overlapping, or is just going to be everything that it says. Okay? All right, are we ready? Sure?
Yes.
Okay. So example 1. So we are going to solve the absolute value inequalities below. We're going to solve the inequality and graph the solution set, okay? So we have, first of all, we just have this one right here. This is our inequality. Where's my highlighter? So I know there's lots of words on this page, so I want to make sure y'all know what we're looking at. This is our problem that gives us the absolute value of 3p minus 12 is less than 9, okay? So since we have absolute values, that means we have to do 2 cases. 2, okay? So case 1, we're going to look right here for case 1, we're going to assume that the inside is positive. So if the inside is positive, is anything going to change?
No.
No. We're literally going to just copy this down exactly as is, except I'm going to just drop the absolute value bars because we're assuming that it's going to be positive on the inside. So 3p minus 12 is less than 9. That's our case 1. Do y'all want to go ahead and solve this one first or look at case 2?
Look at case 2.
Okay, we'll solve it. Sorry. All right, so to solve this, what do we have to do to get p by itself?
Plus 12.
Good, plus 12. So we are left with 3p. Our inequality stays the same. 9 plus 12 is?
21.
21. And now what do we do? Good, divide by 3. So p is less than 7.
So the same rule apply to this one.
Yep, hang on. There's something a little extra with it. Okay. So are we good with case 1? Case 1's our normal stuff that you guys know how to do. Nothing weird is happening. Okay. Yep. Okay. Are we ready to go to case 2 now?
Yep.
Okay. Case 2 has a little tricky trick with it because we're dealing with inequalities. So we have to assume that the inside part now is negative, okay? So we're going to recopy what's inside. So 3p plus, nope, that is a minus. I am so sorry. 3p minus 12. And instead of having a positive 9, it's going to change to a negative 9. Now, pause. Gavin's already figured it out because Gavin's so smart. All right? He is special. He can't help it, but in a good way. That 9 went from a positive to a negative. Its sign changed. Okay, the value changed. And remember, guys, when we switch the sign of something, when we divide or multiply by a negative number, what happens to our inequality? It flips. Because, guys, let's be real. Can 3p minus 12 be less than 9 and 3p minus 12 be less than negative 9?
No.
No, it can't be less than both 9. Well, if there's a little case. But we have to make sure we flip this inequality because we're changing the value by making it a negative. Okay? Are y'all okay with that? Sort of, kind of. Maybe? Okay. So that right there is going to be your trickiest part, honestly. First of all, remembering that there's 2 cases, and second of all, remembering that we flip our inequality. Okay? So now let's solve. Okay, so this changed to a negative. We flipped our inequality. We're solving it the same way. We're going to add 12. Negative 9 plus 12 is? And then divide by 3. So p is greater than 1. Okay. So let's write this. let's write this in our set builder notation. Okay, so I'm going to do my braces. P line. This is going to be an and because it has to satisfy both of these solutions since it's an absolute value. Do y'all want to do the two separate ones inside, or do y'all want to make it the one long one? One long one? Okay. So I'm going to start with the lowest number. So 1 is going to be less than P, which is less than 7. And I'm glad y'all know what I was talking about when I said the two separate or the one long one. Okay, so P is going to be greater than 1 and less than 7. So on our number line, what two numbers do we need? 1 and 7. They're both going to be open circles because neither one of them are equal to. And if P is going to be in between these two numbers, it's an and. We shade the middle. So we're going to shade in between. Okay, questions on that? Where did we get overwhelmed? Nowhere. Just got to practice it. It's easy peasy lemon squeezy. Okay. Alright, so example 2. Example 2 is a little weird. It's my favorite. There will be one of these on your test, and you guys will stress out about it, and then at the very end, once you come ask me a question and I'll shrug, then you'll be like, oh. Okay? So this says the absolute value of x plus 5 is less than negative 10. Now, what do we know the absolute value of this thing has to be? Positive. Whether the inside's negative or positive, the absolute value of it has to be positive. So can it be less than a negative? No. Therefore, this is no solution. Sure. So this says no solution right here. Okay? So the difference in, I know this confuses some people because here y'all are like, well, we made this negative, but we couldn't make this negative until we dropped the absolute value. We're assuming that inside the absolute value is what's negative. Okay? This whole thing, the absolute value of something cannot be negative. We're assuming the inside is negative. Then you take the absolute value and it becomes positive. All right? So here, if you ever have an absolute value of something is less than a negative, you can't have something that's less than a negative when you're taking the absolute value. It has to be a positive, okay? So example 2 is one of those things that you might need to review back to a couple of times before it kind of like, oh yeah, okay? Because some of y'all will solve problems like this. Here's the hint. If you have to make this number into a positive to find your cases, you're doing something wrong, okay? You should only have to make the solution to a negative. Okay? All right, let's look at the back. Alright, so we're solving absolute value inequalities once again, but this time it's going to be greater than, the absolute value is going to be greater than that 4. Okay, so if it's, hear me out, if it's greater, it's or. If it's greater, okay, that's where I'm going to be weird. If it's greater, it's or. If it's less than, it's and. Did I lose everybody just now?
No, I wasn't paying attention.
If it's greater, if the absolute value is greater, it's or. Here, if it's less than, it's and. Okay? Yes. Thank you so much for correcting my grammar. I do appreciate you always. Alright, so less than, if the absolute value is less than, it's and. Okay, trying to get as country as possible here. If the absolute value is greater, it's or. Okay? So that's the best part here. Oh, so glad I got to teach all the day after last night's game.
Yep.
All right, so in this case, we have the absolute value of x minus 7 is greater than 4. So that means it's going to be an OR case, okay? So you get super southern to remember that. All right, let's start with case 1. Case 1 is where nothing changes. We're assuming what's inside the absolute value started out as positive. And so nothing changes. It's going to stay exactly the same. I'm just going to drop the absolute value. So x minus 7 is greater than 4. Nothing's changed. I just dropped my absolute values. I'm assuming everything inside is positive. You're zoned out again. All right, so how do we get x by itself?
Plus 8.
Plus 7. So x is greater than
11.
Alright, so case 1's our normal. Case 2's the one that we don't need to forget about, but it's the one that gets weird. So we will keep the inside of the absolute value, x minus 7. Our solution, or whatever it's greater than, is now going to change to a negative 4, because we're assuming that whatever is in here is actually a negative. The absolute value is what makes it a positive. And since we went from a positive to a negative, we multiplied by negative 1, our sign flips, or inequality flips.
But does that make it no solution?
No. So it's only no solution when it's negative here because the absolute values. Do you see how we already dropped the absolute values?
Yes.
We're assuming that inside the absolute values is negative, not the solution to the absolute value is negative.
Okay.
Okay? All right, so we still have to add 7 to both sides. So x is less than 3. Right. So let's do our set builder notation. Can we write this as one long one?
Yes.
Yes. No.
No. When it's an OR, they have to be separate, okay? So we can do x is greater than 11, then we use the word or x is less than 3. So there is a number such that x is greater than 11 or x is less than 3. And then we can graph this. Which number goes first? 3. Then 11, open or closed? Why? What makes it closed? Since it's just greater than and less than, not equal to, they're open circles. Where are numbers that are less than 3?
To the left.
To the left of 3. I don't know why I did squigglies. I just want to do squigglies. Where are the numbers that are greater than 11? To the right of 11. About to throw things at y'all. No, I'm trying to be good. My coffee's in here. I made it myself from my fridge.
Except in the highest scoring bowl game
All right. We have 2 more example problems, so if we can get through 2 more without having to talk about football for just a few more minutes, that would be great. All right. All right. So example 4. Okay, if example 2 was the no solution, example 4 is the weird one that y'all are going to be like, oh goodness, okay? So here's the thing. This one says,
Okay, so we'll drop
the absolute value of 3x plus 4. Okay, what do we know about absolute values of numbers? They have to be
Positive.
positive, so they have to be greater than a
So it's always true because it's a negative.
Yes, it has to be greater than a negative. So since this says 3x plus 4, the absolute value of this is greater than or equal to a negative 4, this is actually going to be all real numbers. Because absolute values must be positive, and all positive numbers are greater than the negative numbers. Like, I'm trying to make this make sense to y'all. Okay, some of y'all still are looking at me like I'm crazy, though, and so it might take a couple explanations, and that's fine. Okay, but all the positive numbers are greater than all the negative numbers. That's why this one's all real numbers. All the positives are greater than the negatives. Whereas this one, this was saying a positive number had to be less than a negative number, which is not possible. It can never happen. That's what makes this one no solution, and this one all real numbers. Okay? If this is all real numbers, how would we graph that on a number line?
The whole thing.
The whole thing. Okay? It's going to be the whole thing. If the other one's no solution, what does that look like on a number line?
Empty.
It's empty. There's nothing on it. Okay. Huh?
Does every single thing that we do involve a number line?
I just want y'all to understand what that means. Like, as a number line, what does that mean? It means it's literally all the numbers, so we color all the numbers.
I know that.
Yeah, I just want to make sure y'all know what that means.
Do you color the arrows too?
You can. Okay. Are we good with no solution, all real numbers for today, and then we'll forget it tomorrow and we'll talk about it again? Okay. Right. One more problem, example 5. All right. Apply absolute value inequalities for real world problems. There is a formula here you are going to have memorized. Okay. So if y'all want to write this bigger down at the bottom so y'all remember, y'all need to know it. It's the absolute value of x minus the midpoint. Close absolute value. And you're going to have some inequality symbol here. Greater than, less than, greater than, equal to, less than or equal to. So it's going to be pick one. And it's going to be the distance from the midpoint. You guys will see this again on math workshops and other assignments. And every time I have people saying, what am I supposed to do here? I'm like, it's that formula. I don't know what it is, okay? This is where you're going to look back to it for, okay? Back to it too. All right. Huh? You will see this in your math workshops the rest of this 9 weeks.
How do you know which symbol to use?
By reading the problem. Okay.
This is only for word problems?
Okay. So here we have the average depth of a river is 4 feet. So the average is 4 feet. With the rainfall and evaporation, the depth of the river is within, meaning, what does that mean? If the depth is going to be within this amount, it's going to be up or down. A quarter of a foot of the average depth. Okay, so we want to find the range of depth for the river. We're going to use our formula to figure it out. Okay, so I'm just going to go ahead and start with my absolute value, because that's what it's going to start with, absolute value. X minus, now the midpoint. What is the middle of the river going to be? 4. Why do I know it's that 4? Because that's the average. Okay, the middle is going to be like the average, so X minus 4. Close absolute values. And then we're going to pick an inequality in a second. I'm just going to skip that part. And then we're going to do the distance from the midpoint. Well, what's the range from the midpoint? 0.25. So the 0.25 goes back here by itself. Okay. Now, here's the thing. Is the depth of the river, so think about your and or graphs, okay? Is it going to be like an or graph where it's going to be this way and this way, or is it going to be in between something? It's going to be in the middle, right? So if we're looking at the range of waters, it's going to be in between these two numbers. So what symbol, what inequality would make this an and?
mean less than.
Less than would make it and. Okay? So can it also be equal to?
No.
Yes, it can.
If it's going to be within 0.25, I would say yes. Okay? It's less than, because that's and we want our graph, our river would be in between 2 points. The distance would be in between 2 points. Okay? You're not going to have like weird 12 feet of water and then 0 foot water. You have to have those middle numbers. Okay? All right. Does that sort of kind of make sense? This takes a lot of brain power sometimes. Okay? All right. So we've got to solve. Y'all ready? Y'all just want to do the easy one first? Case 1 first. Okay, so case 1 where we drop our absolute values because we are assuming it is positive. Everything stays the same.
Well, aren't you just a smart
Very good. X is less than or equal to 4.25. So that's our case 1. Now on case 2, what are the 2 things that change?
The symbol and the sign.
The symbol and the sign. The inequality is going to flip, and then the 0.25
Negative.
is going to become a negative. So we flip the inequality and change the sign. Then we solve it the same way.
It's 3.
Okay, so x is greater than or equal to 3.75. So what is the range? What is the range of the depths it could be?
It could be less than 4.25 or greater than 3.75.
How can we say that a little bit smoother? It's going to be between what?
4.25 and 3.75.
When we say things are between, do we usually start with a bigger number? No, I just want to pick on you a lot. All right, so we could say our range is going to be between 3.75 and 4.25. All right, so it's going to be almost 4 feet and a little over 4 feet every time, okay? So just wanted you guys to think that one through. Since it is an and, the x can go in the middle, and it would be 4.25, 3.75. And then if we graphed this, our 2 points would be what? Good. Would they be open or closed? Closed. And will we shade outwards or inwards? Inwards. In the middle, because we would want those middle values.
So I can use the restroom now.
You can use the restroom now. Sign out, please.